Hello and welcome to our lesson on angles. So what we're going to talk about obviously in this lesson are angles, but not just the angles that you're probably familiar with. We're also going to talk about angles in what we call standard position and then some common relationships that we need to be familiar with respect to multiple angles. And then finally something we call reference angles, and all these concepts will move forward with us as we progress through the module. So first, just a basic definition. Angles are formed by two rays that share a common endpoint, and that common endpoint we're going to call the vertex of that angle. So if we have two rays, and hopefully we understand that a ray is something like this, where you have an endpoint and then you go forever in one direction. So if you take two of those and put them together and they share that common endpoint there, then we form an angle. And that common endpoint we're going to call, so this common endpoint here, we're going to call the vertex of that angle. All right, so some terminology that hopefully you're familiar with. When you have an angle, and notice there's a variable here if you haven't seen this variable before, that's the Greek letter theta. That's often used to represent an angle. So if we have an angle that we're in this case going to call theta, that measures between 0 and 90. So theta being less than 90 and greater than 0 means it's between 0 and 90. So an angle between 0 and 90, you probably know, is called an acute angle. So this is an acute angle that measures between 0 and 90. When it measures exactly 90 degrees, we saw lots of these in our previous topic, and I don't know why this got cut off. But if our angle is exactly 90 degrees, we know that we call this a right angle. So we saw lots of those right angles in our right triangles topic. If we have an angle like this one, where our theta, our angle is larger than 90 degrees, but less than 180 degrees, so again, the theta being between 90 and 180, again, this is hopefully something you've heard before, that's called an obtuse angle. So those ones, again, between 0 and 90, I don't know why. Did I make all of these plural? Let me go back here. Okay, yeah, singular. All right, when we have what looks like a straight line here, technically there should be a vertex in between, but we rotate our angle so that we make that straight line. We've gone a full 180 degrees because it looks like a straight line. We call this a straight angle. And then this next one might be a new one for you. You've probably seen the first four, but when you take your angle and you rotate it beyond the 180 degrees, but not a full circle like we see on the last picture here. So if we're looking at an angle that's between 180 and 360 degrees, that's called a reflex angle. And then when we go a full rotation, so a full rotation, 360 degrees, and that's probably something we're familiar with. You know, if we do a 360 in some sporting event, you've gone a full circle. So we're going to call this either a full rotation or a complete angle. So this could be called a full rotation, or this could be called a complete angle. Okay, so just basic terminology there. Again, hopefully some of those you're familiar with. But what we're going to be looking at is giving our angles some reference point. So if, for example, I asked you to draw a right angle, of course, every right angle measures 90 degrees, but we could draw these differently. Like maybe you draw your right angle like this, maybe you draw it like this, maybe you draw like this, right? There's all kinds of different ways to situate that right angle. So when we move forward, what we want to do is, again, give our angle a reference point and somehow guarantee that when I ask you to draw a right angle, that every one of you comes up with the same picture. And so what we're going to do is we're going to put our angles on a graph. We put them on a coordinate plane on an x and y axis, and we're going to center the vertex of our angle at the origin. Then we call that angle that's graphed an angle in standard position. So in standard position, trying to move here, an angle is just graphed on an x and y axis. And for example, let me just graph one for you. So let's say I want to graph an acute angle in standard position. When I graph this, again, just to make sure that we're all doing the same thing, we're always going to make the first ray of our angle on the positive part of the x-axis. So our first ray, let's say this is the first ray of the angle that we want to draw here, would be on the positive part of the x-axis. We're going to call that the initial ray. So every time we are drawing an angle in standard position, that's where we put the first ray. So we're going to have our vertex. Oops, that's my eraser. How did I manage that? I don't know. We're going to put the vertex at the origin, and again, that first ray, the initial ray, on the positive part of the x-axis. And then we're going to rotate the other ray to make our angle. So if we wanted to make, let's go ahead and make an angle here. So this second ray to form our angle, we're going to call the terminal ray, because it's the final resting place of that rotation. So this is the terminal ray. And so that terminal ray can rotate any number of degrees up, or technically it can rotate any number of degrees down. So this angle, let's say I wanted to make sure that I was looking at the angle that's rotated in this direction. When we rotate up from the x-axis, we're going to call this a positive rotation or a positive angle. And in this case, it ends up being not just a positive angle, but a positive obtuse angle, because hopefully we see in that first quadrant we're making a 90 degree, right? We have 90 degrees here, so if we go beyond that and all the way here would be 180, so if we're between 90 and 180, we're looking at, again, an obtuse angle. Okay, now, if we do the same thing, let's put our initial ray, we're always going to do that on the positive part of the x-axis, and then we make our ray, terminal ray, the terminal side of our angle here again. But instead of rotating up to get there, if we rotate down to get there, so if this is the angle that we're looking at, then that would be a negative angle. And that would be a reflex angle because it's going the 90 and then 180 and then a little bit beyond that. So this would be a negative rotation, so a negative angle. Again, this is still going to be referred to as the initial ray. This is the terminal ray, or sometimes we call them the initial side and the terminal side. But if we rotate up to create the angle, it's positive. If we rotate down to create the angle, it's negative. And so you may be thinking to yourself, negative angle doesn't make sense. And truly, the measure of the angle isn't negative, so negatives in that way don't make sense. But we're going to use positives and negatives to give us direction. So angle measurements are actually always positive, but the negative is telling us to rotate down instead of rotate up. Okay? So positive angles are angles that are going to rotate up from the x-axis. So we always start on the positive part of the x-axis. If we go up and the terminal side rotates up, we're looking at positive, and if it rotates down, then we're looking at a negative angle. And then if our terminal side actually lands on an axis, so if I was drawing an angle, and you don't need to do this, but if I drew my initial ray here and then my terminal ray here on, let's say, the positive part of the y-axis, we're going to call that a quadrantal angle. Nice fancy word. And that will come back in a little bit later. So let's just fill that in. So this is a, oops, can't spell, quadrantal angle when the terminal side or the terminal ray lands on one of our axes. Okay, so just want to make sure we're clear, not just the positive and negative, but what types of angles are landing where. If we are looking at quadrant 1, I'm hoping we know, like this is the origin of our graph. This is quadrant 1 in our graph. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So if I'm looking at positive angles in quadrant 1, so again, our terminal side, our initial side would be here, and then this would be a quadrantal angle at technically 90 degrees, but anything in quadrant 1, so between those two, would have to be between the 0 and 90 degrees. That's where we're going to have our acute angles. So in quadrant 1, we have all of the angles that are measuring between 0 and 90. So let's say we have, oops, again, it keeps clicking to my eraser, sorry about that, 0 degrees less than theta less than 90. So our acute angles, acute positive angles in standard position, have a terminal side that will land in quadrant 1. Okay, if we have an initial side, again, on the positive x-axis, but our terminal side lands in quadrant 2, what's going to have to be true about the angle measurements there? So, again, this is technically we could say this is 0 degrees here. If we rotate up to the positive part of the y-axis, we're looking at a 90-degree angle, so this is going to be 90 degrees here. If we rotate another 90 degrees, so we make a straight angle, then we're looking at this being a 180-degree rotation here. If we went another 90, this is going to be a 270-degree angle. So if we started here and our terminal side was here, again, that's a quadrantal angle, that would be 270 degrees. And then if we go full 360, we land back where we started on the positive part of the x-axis. So we can say this is 0 degrees technically, or 360. So again, anything from 0 to 90 lands in quadrant 1. If we land in quadrant 2, then we're looking at an obtuse angle, so something between 90 and 180. So this is going to be 90 degrees less than or equal to theta, not equal, but less than 180. We don't want to be equal, because if we were equal to 90, again, that's a right angle. If we were equal to 180, that would be a straight angle. If we land in quadrant 3, so if we have our initial side here and our terminal side lands here, then obviously we're going to be between the 180 and 270. Oops. Get rid of that and that. So in quadrant 3, we're going to... Why? My eraser keeps turning on. We're going to go from 180 less than theta less than 270. And then if we are in quadrant 4, again, we're going to start here if the terminal side landed here. So if we went up and rotated all the way to this quadrant, then we're looking at anything between 270 and 360. Get rid of all these highlights so I don't make a mess of my paper. Okay, so from 270 to 360. Okay, now negative angles, going to be very similar, but we're going the other direction. So if I went the other direction, again, I would start at 0 here, but if I was going to go negative 90 degrees, then I would land here. So this rotation, okay, would be a negative 90-degree rotation. So we can call this 0, and that means this 270-degree angle and a negative 90-degree angle, those are the same place. Or if I went another 90 degrees in the negative direction, then I end up here where positive 180 is. So these are the same. Negative 180 degrees and positive 180 degrees, those are the same place. Okay, if I went another 90 degrees, then this 90 degree, oh my gosh, with the eraser. This positive 90 and negative 270, going to be the same place. And then if I went another 90, then I would end up at negative 360. And negative 360 and positive 360, those are the same place. So if we're looking at negative angles, this time it's in quadrant 4 where we have the acute negatives. So this is where we're going to have the 0 less than theta less than 90, so between 0 and 90. And then quadrant 3 is where we're between 90 and 180 in the negative direction. And I should make negatives here. Not negative 0. Why did I do that? 0 and negative 90. And then if we're going to go from negative 90 to negative 180, then we're here. And then if we're going to go from negative 180 to negative 270, then we're here. And then finally negative 270 to negative 360, then we're going to be here. Okay, so hopefully that gives you an idea, so that if I asked you to draw an angle in standard position or sketch an angle in standard position, regardless of whether it's positive or negative or acute, obtuse, reflex, quadrantal, any of those, you should hopefully be able to sketch this, or at least have an idea of what it's supposed to look like in your head. So that's what we're going to do to make sure that we have grasped what's happening here. And if you want, this would be a good opportunity for you to pause the video and try this out, but we can try this also together. So if I said sketch an angle in standard position, then it's got to be on a graph. So I'm going to make a sketch of an x and y axis. And we always start with the terminal side, or the initial side, on the positive x-axis. So I'm going to make my first ray there. And then if I want to go 95 degrees, positive 95, then I know I'm going to rotate up. And I have to go past the positive y-axis, which is 90, but not quite to 180. So 95-degree angle is going to have to land here in quadrant 2. It doesn't matter exactly where, as long as it's in the right quadrant, we're going to be fine. And then again, I want to make sure this is positive, so I'm going to draw this little arrow saying that I rotated up to get there. And there it is. There's our 95-degree angle sketch. Okay, so let's try this again with 190. So when I graph this, initial side on the positive part of the x-axis, and then I don't want to go 90, 180, I would want to go a little bit more than 180, but not quite to 270. So 90, 180, and then 190, eraser. We're going to land in quadrant 3, and it says positive. I want to rotate this way, so this is approximately what a 190 degree positive angle is going to look like. Okay, or negative 70. So make my axis, make my initial ray. And now I'm going to rotate down, but not quite to 90, so I want to land here in quadrant 4. Again, rotating down, so there's what a 70 degree angle may look like. And then how about 400? We didn't talk about anything larger than 360, but definitely going to be possible. So here's what's going to happen. Start on the positive part of the x-axis like we always do. If I had to rotate a full circle, that would get me to 360. If I went 360, I would still have to go another 40 degrees to get to that 400 total rotation. So another 40 would take me into quadrant 1 again. So my terminal side is going to have to be in quadrant 1. So this is what a 400 degree, or something that's greater than 360, is going to look like. You're going to see a complete circle, right? And then we have to go, as far as we need to go on this one. 40 degrees more takes us into that quadrant 1. And we want to show that arrow saying we rotated that way. Okay, so we can have angles that are larger than 360 that are more than one full rotation. All right, next set of questions here. If we want to sketch this, we can, but we're just trying to decide where the terminal side of each angle lands. Is it quadrantal or on one of our axes, or is it in a quadrant? So a negative 100, I'm going to go ahead and sketch it just because it makes it easier for me to describe. But if I was to sketch this, right, my initial side, negative 100, so negative 90 would be here. I'm going to go a little bit further to make the 100, so there's my terminal side. And I can see that that terminal side lands in quadrant 3. So that would be the answer here, technically. This terminal side lands in quadrant 3. If I was to sketch 285, here's my initial side, and I'm going to go positive. There's 90, 180, this would be 270, and I need to go a little bit more, but not a full rotation, so terminal side is going to be here, and that's going to be in quadrant 4. And then negative 190, so initial side is going to be here, and then I want to go negative, so I'm going to rotate down. This would be 90, 180, and then a little bit more. So terminal side is going to be here, and that ends up being in quadrant 2. And then 720 is going to be, again, more than one full rotation. How much more is the question? So initial side. If I want a full rotation, that's going to be 360 and positive, so I went up. So 720, if I take away that full rotation that I've already done, I'm actually left with another 360. So I have to go another full rotation to land right there. So my angle is going to start and stop on the positive part of the x-axis. So this is a quadrantal angle. So this terminal side lands. If I said where does a terminal side land, we know it's quadrantal, but we would say it's on the positive part of the x-axis. So that would be the landing spot for our terminal side. This is again a quadrantal angle. Wow. Sorry, I'm on the edge of my iPad, and so trying to keep the pen on here. Okay, so there we go. Alright, hopefully we have an idea now what these look like, how our positives and negatives work. We can sketch and figure out where terminal sides are going to land. Next, what we're going to do is talk about some relationships between multiple pairs of angles. And the first two I'm hoping you've heard of before. If we have two or more angles, positive angles we're talking about, that add up to 90 degrees or that form a right angle, we're going to call those complementary angles. So complementary angles are positive angles that have a sum of 90 degrees. That means they are forming a right angle like the picture that we see here. So if I gave you these two angles and I can see again that they are making that 90 degrees, then we should be able to, in a situation like this, figure out the value of x, set up an equation to solve. So I know if I was to add, in this case, the 35-degree angle with the other angle, which is given to us as 4x plus 7, that those two together have to add up to 90. Now I put parentheses because it's good practice, but they don't really do anything to this problem. So I'm going to go ahead and drop them here. So distributing 1 does nothing. I'm going to combine my like terms, which in this case are the 35 and the 7, and 35 plus 7 is going to make 42. So 4x plus 42 is equal to 90. And then I'm going to subtract that 42 over. So that's going to leave us with 4x equal to 48. And then if I divide 48 by 4, I find that x is going to be 12. So if I said to solve for x, we would be done. And we could also then use that to make sure that we did this correctly. If I plug the x back in here, 4 times 12 would be 48. 48 plus the 7 is going to make 55. So this is a 55-degree angle here, and if I was to add the 35 and 55, it does in fact add up to 90 degrees. So if I wanted to check my work, that would be a nice way to do that. Okie doke. So complementary, again, hopefully something we've seen before, as well as this is something we've probably seen before. If instead of our positive angles forming a right angle and adding to 90, if they form, like in this picture, a straight angle, then they're going to add up to that straight line measurement, which is 180 degrees. So we're going to call these supplementary angles. Supplementary angles add to 180, they form a straight angle. So then again, I could ask you to solve for x in a situation like this, knowing that these three have to make a total of 180. So I take the 5x plus 4, add on the x minus 2, add on the 3x plus 7. Again, these three all together make a straight line. They make 180. Let's combine like terms. 5x's plus 1 more makes 6, plus 3 more makes 9. So I have 9x's. And then let's combine the constants. So 4 minus 2 is 2, and then 2 plus the 7 is 9. So 9x plus 9 equal to 180. Now we can subtract that 9 over. So we have 9x equal to 171. And then just making sure I copied everything down right here. Okay, so we have 9x equal to 171, and then we're going to divide both sides by 9. Does 9 go into 171? I made an ugly problem here. Yeah, no, it does divide. Okay, what did I say? 19. Sometimes my brain doesn't want to do all that math. So 9 goes into 171 19 times. Alright, so there's our value for x. Now I could also use this to ask you to find the measures of the angles. Again, a good way to check our work. We plug this back in. So if I plugged back in here, 5 times 19 plus 4, that would be, let's see, trying to do math and not so much. 19 times 5, which is going to be 95. Yeah, see, I was going to mess that up in my head. And then I'm going to add 4. So this is a 99-degree angle here. It's late at night, guys. I'm really sorry. Plug it into the second one. So if I have 19 minus 2, obviously that's going to be 17 degrees here. And then 3 times 19 is going to be 57 minus the 2 would be 55 degrees here. So 3 times 19 minus 2. And then we can just double check. If I add up 99, 17, and 55, I get not 180. What did I do? What did I do, folks? I'm losing it. That's 9 x's. 95 and 4. I did that right, right? Okay, let me just double check my math. You're probably knowing what I did and listening to me struggle. I apologize. And then 19 minus 2 is 17. And then let's just check the last one. 3 times 19, which is 54. Oh, where did I get the minus? Jeez. Sorry, on this one I did a minus 2. Not really sure why I did a minus 2. But 3 times 19, and then it should be a plus 7. Holy moly. 3 times 19 plus 7. So that should be a 64-degree angle. This is why we check our work. Okay, so now 99 plus the 17
plus the 64, and there it is, 180. Goodness, I thought I solved the equation wrong, and I was really going to be mad at myself. Okay, so we're good. I just plugged something, I don't know, messed this up, put a 2 there. All right, so we're good. We got x there. Complementary, supplementary, again, hopefully things you've seen before. This next one might be new, depending on how much experience you have with trig, but if we have distinct angles, this means we have angles that have different measurements, but they have the same initial and terminal sides. That means they start and stop in the same spots, but they're distinct measurements. They're different measurements. We're going to call these coterminal angles. Should make sense because their terminal sides are the same, and all angles in standard position have the same initial side. So coterminal angles. These are distinct angles. They have different measurements, but they have the same initial and terminal sides. Well, all of them in standard position have the same initial side, but the terminal side is the same as well. That means they're landing in the same spot. So let me show you, and then I'll fill in that last blank. So I have in the picture, the same picture twice on purpose, the first angle, that positive 210 degrees, instead of rotating up to get to that 210 degrees, if instead I rotated down to get to that same terminal side, then this angle starts and stops in the same place. Same initial side, same terminal side, but one rotates up to get there, one rotates down to get there. Those are definitely distinct angles, but they land in the same place. So those would be what we call coterminal angles. Now, what would the measure of that second angle be? So if I went up 210 and then I went down to that same spot, what I'm making there, hopefully you can see this, is a full circle. So there's 360 degrees total there, but 210 of them went up, the rest went down. So if I took 360 degrees and subtracted out the 210 that I rotated up, then I have 150 degrees left for that angle that rotates down. So this is 150 degrees, but because it rotates down, it's negative. So we would say that 210 degrees and negative 150 degrees are coterminal angles. Okay, so one way is just to go the opposite direction to find a coterminal angle, or we can do this. In the same angle, instead of rotating up this 210 degrees and just stopping there, if I just kept rotating a complete circle and then stopped here again, right? Just add on a complete circle. So I have that initial 210 that I did, and then I add on a complete circle from there, then I'm going to land in the same exact spot. So those would be two coterminal angles, but I'd have to add the 360 to the 210. So if I have 210 and I just add on a full circle rotation, I'm going to land in the same spot, and that's going to be true for any angle. If I just add a full circle, a full rotation from where I ended before, I will have a coterminal angle. So then we would say that angle is 570 degrees. So 570 degrees, and I still went positive from that direction. 570 degrees and 210 degrees start and stop in the same spot. Those would be coterminal angles. So you notice the trend in both of these. I was taking away from 360, adding to 360. Any pair of coterminal angles differ by 360. So if you're adding and subtracting multiples of 360, so add it once, or I can add it twice. I can add another 360, go another full rotation, and get 930. That would be another coterminal angle. Any amount of times I do that. So and subtracting the same way if I wanted to go in the negative direction. Our coterminal angles differ by 360 degrees. Okay, so we can go adding the 360s or subtracting the 360s. We're going to start and stop in the same spot. Hopefully that makes sense. Now let's do a little bit of math here to make sure that we've grasped this. Again, this would be a good place for you to pause the video if you want to try this out. But if I said find the complement and supplement of an angle, we should be able to handle this. Remember, complementary angles, these make 90, and then supplementary angles, these make 180. So if I said to find the complement of an angle, I need to know what would I have to add to it to get to 90. If I want the supplement of an angle, what do I have to add to it to get to 180? So the complement here, if I take the 90 that I'm trying to get to, take the 75 away that I already have, I know the complement's going to be 15 degrees. That the 15 plus the 75 would make the 90. Or the supplement is, what do I have to add to 75 to get to 180? So let me subtract the 75 out. That would be 105 degrees. So the complement of 75 is 15. The supplement for 75 is 105. And the same thing here. So I have 90 degrees. Take away the 32 that we've already got. And 90 minus 32 is going to be 58. So the complement of 32 degrees is 58 degrees, because 32 and 58 would make 90. And the supplement is going to be 180 minus the 32. So it's going to be 148. Checking my mental math. 148 degrees would be the supplement. 148 and the 32 would make 180 altogether. Okay? So adding and subtracting, subtracting from 90 and 180, and we're finding complements and supplements. Now, if I ask you to find coterminal angles, there are a couple different ways I could word this. But in general, when you're asked, what you're going to look for is the angle of least positive measure. So the smallest possible positive angle that would be coterminal with the one that you're given. So remember, coterminal is going to differ by 360. So for 95-degree angle, if I just add 360, I'm going to get the smallest possible coterminal angle, the smallest possible angle, positive angle that lands in the same place. And just so I don't goof this up, because it's a tired brain, 360 minus the 95 is going to be, not minus, see, I'm even messing up the calculator. 360 plus the 95 is going to be 455 degrees. So that would be the smallest possible positive angle that I could make that would have the same initial and terminal side as 95. Same thing here. I have a negative 150. If I go a full rotation from there, add 360 degrees. I could do this in my head, but now I'm second guessing everything I do. Positive 360, negative 150, that would be positive 210. And that's actually the one that we saw in the picture, right? So this is working in reverse. Instead of giving you the 210 and finding that the negative 150 was our coterminal angle, I gave you the negative 150, added on the 360, and we got to the 210. Okay, so same problem, just a different way to approach it. Now, a negative 603. If I want to find a positive angle, I'm going to have to add, again, 360 to this. But when I take the negative 603 and add 360, I'm still left with a negative angle. I'm left with a negative 243 degrees. And I'm looking for the smallest positive angle that's going to be coterminal. So I'm going to just add 360 again. So let me add 360 again. Another full circle, I land in the same spot, and now I'm at 117 degrees. And now that we're positive, that's going to be the smallest possible positive angle coterminal with negative 603. So if I was to draw, graph, sketch a negative 603 degree angle, a negative 243 degree angle, and a positive 117 degree angle, all three of those sketches would be the same. They would start and stop in the same place. Okay? Hopefully this is making sense. And then one more. So we already have a positive angle here, but I'm looking for a small positive angle that's going to be coterminal. So this time, I'm going to subtract out multiples of 360 to find out what's the smallest angle that's going to start and stop in the same spot. So let's subtract out the rotation because there are already so many here. So this was 1106. Let's minus 360, and that takes us to 746. So that would be coterminal, but I can go smaller. So let me take out another rotation. That's going to be minus 360 is going to be 386. Again, that's going to be coterminal, but we can still go smaller. So let's subtract 360 again. And then we're left with 26. And if I tried to subtract 360 again, I'm going to go negative, and I'm looking for the smallest possible positive, so we're going to stop there. So 26 degrees is going to be the smallest coterminal angle that is positive. Again, if I graphed this, all four of those angles, they start and stop in the same spot, but the 26 is the smallest of those. So there we are. And I guess I should box these answers in, maybe highlight them. Got some inconsistencies in my work here, so sorry. Sometimes I box and sometimes I don't. If you have OCD, that's probably going to bother you. All right, one last concept. before we call it an evening here. So, well, might be the morning for you. The last thing we're going to talk about is what we call a reference angle. If we're given an angle, we're going to call it theta. Remember, that's a good variable we use for theta in standard position. The reference angle, which we'll call theta prime, that is associated with the angle that we're given, is going to be either an acute or right angle that is formed by the x-axis and the terminal side of theta. And so when we're looking for a reference angle, and that's probably not a great description, but when you see it, it will make sense. When you're looking for a reference angle, you're looking for an acute or right angle. So not just between 0 and 90, but it could actually be 0 or 90. And it's going to be an angle that takes the terminal side of the angle that you're given and finds the quickest way basically back to the x-axis, whether that's the positive or negative part of the x-axis. So let me try to show you what I mean here. If I was to sketch out a 120 degree angle, I know that I'm going to start here and I'm going to rotate 90 and then not quite to 180, so I'm going to land something like here. Okay, so this is what my 120 angle approximately would look like. So let's say that theta is 120 degrees. The reference angle is the acute or right angle that is going to be formed by the terminal side, so that's this side here, and the x-axis. What's the quickest way to get that terminal side back to the x-axis? So I can take it back to the x-axis rotating this way, but that's more than 90 degrees. That's 120 degrees. So that's not the angle I'm looking for. What I'm looking for is this angle here. This would be the smallest angle, right, that's going to get back to the x-axis. So that angle right there is going to be our reference angle, our theta prime. So we're going to say theta prime is, well, that would take us to the full 180. So if I had 180 degrees and I subtracted out the 120, which is the original angle I drew, I'm left with 60 degrees. That's our reference angle. So we would say theta prime is 60 degrees. Okay? So reference angles are always going to measure between 0 and 90 inclusive, right? So they could also be 0 or 90. So basically what we're trying to do is take the terminal side of the angle we're given and get back to the x-axis. What angle takes us the shortest distance or the shortest rotation back to the x-axis? So let me try to show you that again. I don't know if I'm explaining that very well, but in my head it makes sense. Okay, so a 225 degree angle. We're going to start here, and we're going to go 90, 180, and not all the way to 270. So we're going to land in here. Okay, so we're going to say theta again is 225. And what I'm trying to do is take this terminal side and find the smallest angle between that terminal side and the x-axis. So again, there's a couple different ways to get back to the x-axis. I could go back to the positive part here. That's too big. I could go back to the x-axis here. Again, bigger than 90, that's too big. Or I can go back to the x-axis here. And that's precisely the one I'm going to look for. That is the acute angle, the smallest way to get back to the x-axis, whether it's the positive or negative part. So this angle right here, this is our reference angle. Just got to figure out how much it is. So we had a 225 degree angle total that we drew there. What I want to do is subtract out the 180, and that's going to leave us what we have left for the reference angle. So 225 minus 180, should have put an equal here, is 45 degrees. And so we're going to say our reference angle is 45 degrees. Let me move this over. So theta prime is 45 degrees. Okay? And you're going to see the pattern of basically adding or subtracting from 180 and possibly 360. So if you can do this without drawing the picture, that's great. But if this is still like you're wrapping your brain around, I think the picture is super helpful. Eventually, you're going to get really good at this, though. All right, so let's get a 45 degree angle. So initial side, 45 is not going to go to 90. It's going to land here. So this is what a 45 degree angle would look like. Again, you're trying to find an acute angle, or maybe a 90 degree angle, that gets me back to the x-axis. So think about all the options. So here's our terminal side. Oh, that's my eraser. Here's my terminal side. And if I want to go back to the x-axis, I can do that here. That would be an angle that gets that terminal side to the x-axis, but that's too big. I could go all the way around. Obviously, that's going to be too big. The quickest way back to the x-axis is the actual angle that we drew. And so sometimes your reference angle and your given angle are the same. So in this case, theta is equal to theta prime. So both angle and reference angle are 45 degrees. So anytime your angle is going to be in quadrant 1 or the quadrantal angle 90 degrees, then your reference angle and your given angle are going to be the same. And alright, let's look at a bigger angle here. So we got 330 degrees. So we're going to start here. And then we have 90, 180, 270, so 330 is not a full rotation, it's going to land here. So that's what your 330 degree angle looks like. Smallest angle that takes this terminal side, this one right here, back to the x-axis is going to be this angle here. So we want to complete that circle. So if my given angle is 330, I can see my reference angle makes a full circle there. So I'm going to take 360 this time. Take my 360, subtract out the 330 that I already put into that circle, and that's going to leave me 30 degrees. So this theta prime, this reference angle, is 30 degrees. Okay, now if you're feeling pretty good about this, again, this would be a good place to pause the video and try this out, but I'm going to go ahead and do a couple more with you here. So negative 225. So we're going to start here, and then if I went negative 90, negative 180, this would be 270 to the next axis too far, so we're going to land here. So a negative 225 degree angle is going to look like this. And so I want to take this terminal side and get back to the x-axis. Shortest route there is going to be this angle right here. That's going to be our reference angle. So we have our given angle at negative 225. What is the measure of the reference angle? And if you're thinking about positives versus negatives, remember our reference angles are always going to be between 0 and 90, so these will always be positive angles. We don't have to worry about the direction of rotation. But we got to figure out how big that angle is. So again, we had a 225 degree angle. Let's subtract this part of it out, that 180, to figure out what's going to be left for that reference angle. So minus 180, and now we're looking again at 45 degrees. So another reference angle of 45 degrees. Alright, last one. So last one, 420 degrees. How's that going to look? Oh, negative 420 degrees. So there's our start. And we're going to go full rotation. That would be 360. And that is a terrible looking circle. So a full rotation is 360. If I have 420 and I take 360 away, what's left there? So that would be... sorry, I can't math. 60 degrees. So I want to go full circle and then another 60 degrees. My terminal side then is going to land in here. Okay, so we're going to say theta is negative 420 degrees. Okay, reference angle is again take this terminal side and get back to the x-axis the quickest way possible. So reference angle is going to be this angle that's happening in here, and I just did that work. So if I take my 420 degree angle that I drew and get rid of the full rotation part of it, right? Get rid of that 360. Then what I have left is that 60 degree chunk that went into quadrant 4. So our reference angle is 60 degrees. Okay? Hopefully that makes sense. And again, eventually you'll see the patterns. You'll get good at this. You could probably do it without drawing the picture. And it's going to be helpful to be able to do that because this is something that's going to carry over to multiple sections as we move. So hopefully you're good. You got enough to get you going on your practice. If not, bring questions to class. I'm more than happy to help. All right, that's it for now. Until next time, take care.